Now, I hope I remember about 15 minutes before. No, I don't know. Anyway, the problem is that it takes a while, after I shut it off, it takes a while to, I don't know, to finish. It takes like 10 minutes. So I hope I remember to do it. Anyway, okay, so, all right, now let's just first look at the syllabus, wherever that is. Here. Syllabus is here, 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 statistics. Oh, I'm sorry. Would anybody be so kind as to help one of our students who forgot her password and login for the computer, so she can't log in today? Actually, yeah, if you want, does anybody want to volunteer to lend their password and username to that student? Nobody's comfortable doing that?
I think actually you can use the fresh.
What is it?
The name is fresh and the password is capital the first letter, fresh.
Can you write that up on the board? Thank you. Okay, that's great. Thank you so much. Okay, so if you forgot yours, you can apparently you can use that. Okay, so here's the syllabus and the lesson outline, and requirements. Where's that? Happened to that? Okay. Requirements for the students. The access card for the following books should be purchased in the first week of class. Introductory Statistics, 7th edition. The online system is Wiley, and the access card will be available at the co-op. You will buy this access card at the co-op. So we're going to be doing all of our homework, and the book and so on is all online on this Wiley publishing site. Wiley is the name of the publisher. So you need to go to here, so why don't you do that now? Now, I have another class where we use an online system also, and for that, it's a different online system, just a different company. And for that one, they allow you, I think, 10 days where you can log into the class and use the system before you actually have to pay, which is good because some students aren't sure if they're going to take the class, and so they can check it out for the first week and then decide. Now, I'm not sure if this system is the same or not, so let's see. So when you go there, what do you see? Let me see what you see. You don't want to do already have a Wiley Plus account, so you have to do create an account. So let's try that. So click on the right hand side, it's create an account. And then on the right hand side, yeah. And then you do I agree to these terms on the left, bottom left, and then click continue. And then, okay, so it said, oh good. Now don't say let's see. Okay, click on this. What's this down there? What's that thing? Registration codes are used. This can be purchased separately. No, don't do that. So maybe they don't give you this grace period. So you have to say, I have a, can you just click on the bottom one for a second? See if I can see. No. Okay, okay. And the top one, what about the top one? Okay, so you can't, I have the registration, click on I don't have the registration code. No. Okay, they don't give you the grace period. So you have to buy the code before you can even register. Okay? So you have to do that this week, right, as soon as you confirm that you're going to take this course. Okay, because we'll have homework assignments that are due next week. And generally, the homework assignments are due the night before we meet. So we're going to meet next Friday, so it'll be due on Thursday at midnight. Okay, in general. And once you are able to get in, you'll see something like this. This is mine, so I'm the instructor, so it might be a little bit different, but it should be similar. So it says read, study, and practice, and then the assignments. So read, study, and practice is the access to the book, and the assignments is obviously the access to the assignments. And this class currently has 0 assignments. And maybe there are class announcements that I might post, and they would be here. So if we look at the book, looks like this, and we have chapter 1, because we're in chapter 1. So we have these sections here, and oops, sorry. And we have, let's see, Student Solutions Manual for the chapter, so it has answers to a lot of the problems, and Student Study Guide for chapter 1, and Minitab manual. Minitab is a software program, but we're not using it, so you don't have to do that. And Excel, I don't know if we'll use Excel. Excel is really great for doing a lot of statistics and easy to use. And then this is like for a certain kind of calculator, TI-84, Texas Instrument 84, but we're not going to be using that. And here are data sets that are referred to in the text. Let's see that, data sets. So, okay, so the data sets are in Excel versions and also text delimited versions, or tab delimited versions, or I'm sorry, comma or tab delimited versions. It's similar to Excel actually. Let's just open this and see what this looks like. Okay, so it downloads, and then open it, and here. And so these are different data sets that are referred to in the text. Let's see, McDonald's, I was talking about McDonald's, let's see what they have about McDonald's. So, okay, so let's look at this. So, they might even have problems that refer to these data sets as well. So if we look at the headings, let's see, make it easier to read. Okay. So we have the menu items, right? Hamburger, cheeseburger, double cheeseburger, McDouble, all these different menu. This is great, actually. I didn't know we had this. And then you get the serving size in ounces instead of grams, and the serving size in milligrams, and the calories. Wow, this is really good. And the calories from fat, and total fat, and lots of other stuff, right? Okay, so this is data. This is a lot of data. So actually, we can, in our data mining class, maybe I should use this. Okay, so you can see that they give us access to a lot of data apparently. Okay, there's other stuff, movies, basketball, city data, road race data, and so on. Okay, and then you can go back to you can check chapter 2. And there's again a bunch of, here's the text, and the review test, and the mini project, which I might assign you to do some mini projects. Let's see what this one is about. Mini project, using the data you gathered for the mini project 1, or mini project in chapter 1, so apparently you had to gather some data. Prepare a summary of that data set that includes the following. Prepare an appropriate type of frequency distribution for one of the quantitative variables, and then compute relative frequency and cumulative relative frequencies. So I guess we have to cover that. I don't like covering that because I'm bored with it, but I guess that's my job. Create a histogram, a stem and leaf plot, display a dot plot, and so on. Okay? So this would be a mini project that you would do to analyze a certain set of data. Not to analyze it, I should say, to summarize it. We say to summarize it. Anyway, okay? And then there's other questions here as well. So I'm sure this is all very good. This is a very good book. And if you, I recommend that you use it and you read it well and carefully, you'll really learn a lot. It's very rich in terms of what it does, and it's I think it's very clear. Some people will tell you that statistics is not easy, and I would agree with that, but I know that this book is very good, and it explains it carefully. It doesn't mislead you in any way. It tries to be very careful. So I think it's good. That's why I chose it. So anyway, that's the statistics. That's this interface. Okay, so, and here again is the address in case you didn't get that. Okay, now, also, we are going to learn at least the basics of a programming language for statistics. And this is actually the most powerful, most popular programming language for data mining as well. So when you learn this, you're really going to get a jump on this field. Now when people go to apply for jobs in data mining, if you know this language, if you have some facility with this language, it's a big plus in terms of getting a job. And we're at least going to do some basic stuff with it. Okay? So what I want to do is go to that site. So I found a really nice online tutorial, very simple and easy, and so we're going to use that. Now, though, before we do that, I want to show you how you can get this software and download it onto your home computer for free. It's always free. It's not like there's only one place where it's free. It's free. It's free software. So if you type in R programming, because that's the name of the language is R. So you type in R programming like that, okay, and hit enter. And now there are a lot of courses that you can check online. This company, by the way, is the best, in my estimation, for any kind of learning, online learning, or one of the best. For advanced learning, this is the best. It's called Coursera, and basically it's all the best universities in the world offering online courses for free. Okay, it's really good. But anyway, that's not what we're doing. We want this one. It's called r-project.org. Okay, can everyone find that? So my results are probably different than yours because I'm logged into Google. Okay, so anyway, but you must all have this, right? Everybody has the R project, right? Here, this thing here, right? So click on that. Everyone have that? Or not? Anybody not have rproject.org? Anybody not have it? Okay. So click that, and you get this. And this is the site for R. And we want to download R, so that's here. Now, they keep this R package stored on many, many servers throughout the world. Many sites, many universities agreed to store it there so that it's quickly downloadable. So from many different sites. And those are called mirror sites. So if you click on here, you have all this list of where you can download it from. So you can download it from any of them, but whatever you want. Okay, so just click on one of them. And you should get this, right? And then depending on whether your computer is Linux-based or Mac-based or Windows, you'll select one of those. So we're on Windows, so we'll select that. Okay, so everyone get there? And then you have this thing where they say the base and the contributed and the art tools. So the base is basically the whole thing, except that R has this great feature, and that is that researchers from all different fields will often take their newest results, their newest theories, and code them in R, and then upload them here so that you can run all of the stuff that they've developed for free. So this makes R super, super, super attractive and powerful. Okay? And there are, last time I checked, which was a few months ago, there were over 5,000 packages. And that's what makes R so powerful. So there are commercial software that we can use. We even have here at APU something called SPS, which is very good, but it doesn't have anything like that. You know, it just has the very basic, where it has basic stuff. Okay, but this has like so much stuff that's cutting edge, and it's all free. Okay, so that's one of the main attractions of R. But anyway, we only need the base. If you want to write a thesis at the end of your 4 years at APU, you might want to go through here, the contributed packages, and find something that's going to really help you in terms of doing some kind of advanced thesis. Okay, but we don't need to do that here. So we just do base. And then they keep upgrading it. So the current version is 3.11. So we'll download that. And then it could take a long time because today and yesterday APU's computers are really slow. And it doesn't seem to be working. Actually, I tried it also yesterday and it wasn't working. But it's easy. You just download it, click, 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 and it's installed, and then it's fine. Okay, I don't know. I did this yesterday. I waited for a while and it wasn't working. Okay, yeah, so some people's work, but I don't know, for some reason mine isn't. Anyway, so that's okay because fortunately in this room, and maybe in some others, we have R already installed. So every time we meet, you don't have to install it, right? So it's already there. So if you click on here, and you go to Programs, and you find it here, R. Now R is kind of not so attractive because it's kind of, it's a command line interface. That means you have to type commands and stuff like that. People don't like that, but that's the way it is. Now there are some additional packages. Remember I said that there are all these packages the contributed packages. There are some packages that are written that allow you to use a point and click kind of interface for the basic stuff in R. And we're only going to be using the basic stuff in R anyway, so we could do that, but I'm not going to. But if you want to, you can. It's called Rattle, R-A-T-T-L-E. And you can find that and download it, and that'll be just like it'll look like a little bit like Excel. Not Excel, but it'll be point and click and menus and all that stuff. Okay, so if you want to use that, you can. It's called Rattle, and you can install it on top of R, basically. And you can then use these point and click, and it actually runs the commands that R needs. Okay, so it's just an easier way to run those commands. But we're not going to do that, because it's good to learn how to do it at the base level. Okay? So you go to here, you go to R, and there's actually an older version of R on there, but we shouldn't use that. So we'll use this one, 3.11, and open it up. And unfortunately, like I said, it's a command line interface, so it's not so friendly. Okay? Now, one thing is you can make the fonts a little bit bigger by going here to GUI preferences. GUI means graphical user interface. Graphical user interface. So you can go to that, and you get this, and then you can make it bigger if you want. So I'll make it bigger so that everyone can see. And you click OK. Okay? And then if you wanted to add extra packages, like we said, there were all those extra packages, you could do that, by the way, from here. So let's just see the list of packages. I want to show you how big this list is. So you go to here, Packages, and it says Install Packages. Now before you install a package, it's going to ask you which mirror site you want to use to download it. But that's, so you can choose any one again, just like before. So it says which mirror site do you want to use, from where. So I'll go to Japan. Okay. Click OK. And here's the list of packages. And you can see how small this little scrolling bar is. That means it's big, right? So if you scroll down, you see that there's so many packages here. And like if you buy commercial software like SPS, you might have, say, in total, like the number that are from here to here. So you get all this extra stuff in R. Okay? And there's all kinds of stuff in science and chemistry and physics and biology and business and geology and everything. It's just marketing, everything. Okay? There's so much stuff here. Okay, but anyway, we're not going to do that now. So let's explore some basic R right now. So suppose you wanted to know what 1 plus 2 is. You were really thirsty to understand what 1 plus 2 was. So what you could do is write 1 plus 2. And then hit enter. Okay, very good, right? And if you really wanted to know what 5 plus 6 was, you type 5 plus 6 and enter. And get that answer as well. And if you wanted to know what 10 divided by 2 is, you could do this, 10 slash 2. And you would get that. And if you wanted to know what 10 divided by 3 was, you could do that. Okay? And if you wanted to find the, so this is basically, this is our interface, and this is the way it works. Now, usually you're not going to do these kinds of calculations in R, but this is the way it works. And if you want help on some function, so we're going to see in a minute that there's a function called the sum function. And if you do sum of 1, 3, 7, that's going to give you the sum of those three numbers. And that's called a function, the sum function, right? And functions, we know they're functions because they have brackets, okay? And just like in regular math, when you have a function like this, right? And usually we call x, I wish I had a better. Okay, we call x an argument of f. That's just the terminology. It's called an argument. Okay, it just means the thing that you're putting into the function. So we're putting into the function three things here. What are they? 1, 3, and 7, right? So we'd say it has three arguments. Okay? So x is called an argument, and so in general, here we have three arguments, so we could have three arguments here, general arguments like that. So there'd be three arguments, right? And so functions are, whatever the name of the function is goes first, so it could be sum, and then an open bracket, and then the arguments that that function can accept are listed, and they're always separated by commas. Okay, so in here, how many arguments did sum have in this particular example? 3, and how many commas were there? 2, right? So if you want 3 arguments, you need 2 commas, right? So you can use that to see where the arguments are. Arguments are always separated by commas. So if you want to find the next argument, you go to the comma. And sometimes a little not as clear as this, it's more complicated. So it's a little hard to say, oh, where are the arguments, where are the arguments? But if you use that comma thing, comma idea, then you'll know where the arguments are. So, like there's another function called mean, and you might have mean of 1, 3, and 5, for example. Of course, there are how many arguments here? 3. And what do you think this will give me? In fact, we can type it in a minute, but what will that give me? The mean means what? What's mean is another word for average. Mean is another word for average. Actually, average is kind of more general than mean, but mean is what you usually think of when you use the word average. Okay, actually average has a little bit different meaning, a little bit broader meaning than what you normally think of when you use the word average. So anyway, so what is this going to give me then? 3, right? The average of those 3 numbers is 3, right? Okay, so you can type that in your R interface. And what do you get? Oh, that didn't work. Huh? Oh, I'm sorry. I'm wrong. Okay, let's see why I'm wrong. That's not the way, the mean doesn't work the way sum does. The mean doesn't take all the arguments and find the average of them. It works like this, actually. Type this, 1, full colon, 8. Type that, 1, full colon, 8, and hit enter. What do you get? You get 1 through 8, right? You get a sequence of numbers 1 through 8, right? Type 5, full colon, 20. What do you get? You get the sequence of, right? Okay, everyone see that? So in other words, using this colon, generates a sequence, right? Okay, how about this? Type 20 full colon 13. Okay, everyone get it? All right, so now try this. Mean, open bracket, 1 full colon 5. Well, did we do that before? Let's do 1, okay, 1 full colon 5. So what is 1 full colon 5 before we finish this? 1 full colon 5 will give us what? The sequence of 1, 2, 3, 4, 5, right? What's the mean of 1, 2, 3, 4, 5? I mean, you should know that. What is the mean of 1, 2, 3, 4, 5? No? You can't figure that out? Huh? It's 3, right? The mean of 1, 2, 3, 4, 5 is 3, right? So, so what should I get when I do this? I should get 3. So, in other words, it only takes the numbers in the first argument and calculates the mean. That's why here, what was in the first argument here? 1, right? 1 is the only number there, right? There's not 1, 2, 3, 4, 5 there. It's remember, where are the arguments? They're separated by commas, right? So what's in the first argument here? 1, only 1. So it only calculates the mean of what's in the first argument. What's in the first argument here? There is no comma here, right? There's no comma here, right? So this is the first argument, and that's all there is. So in the first argument, there's 1, 2, 3, 4, 5. So it takes the mean of that. Okay? That makes sense? That was a little more advanced than I meant to do right now. But anyway, is that clear? Okay? So it calculates that. Now these other arguments have some other significance for this mean function, for the mean function. Okay? Now, the next thing I want to tell you is how to get help on a function. Okay? So if you want to know about this function, like I didn't know that, it doesn't work like this, right? So I want to get help on this function, you can get it. Now, unfortunately, the help documentation is more complicated than the program, than the language itself. It's not so easy to read. And so we'll have to spend some time together trying to figure out the documentation. It takes a long time to figure it out. I mean, you can kind of get what it's doing, but it's not so clear. Okay? But let's try it anyway. And the way that you do it is you use the word help, and then you put inside, it's actually a function, the help function. So you put inside there the name of the function you want help on. So what I mean by that is you do this. Okay, you do that, and you hit enter. And you get this. And this is the help for, and I don't think it's that simple to understand, but it says, let's just try and read a little of it. First of all, it says mean, and this tells you the package that it comes from. And it doesn't come from one of these new contributed packages, it comes from the base package. Okay? In fact, we didn't install anything other than the base package, so it would be surprising if it did come from anywhere else. I'm sorry, we didn't install anything. They installed it, and I don't think they installed anything other than the base package either. So, description. It's a generic function for the trimmed, of course you don't know what that means, arithmetic mean. So the formal name for this is arithmetic mean. Okay, but you can just use the word mean. And then here's how you use it. So that not so clear, right? X is is in the first argument, right? Right, you can see that, right? X is the first argument, right? So X can be a list of elements for the first element. Then apparently it has other arguments, but they're not necessarily explained right now. Okay, and then it says this stuff. So apparently we probably put, remember we wrote what? What did we write? What did I ask you to write? Here, mean 1, 3, 5, right? So apparently I probably put, so 1 was the x argument, and then I guess, where is it? What happened to that? Now where is it? What happened to it? Yeah, oh, here it is. Thank you. Okay, so I put 1 in for here apparently, and then the next one, here's the next comma, right? This is again kind of confusing, and so I can't really explain it. I mean, but basically I put 3 here, and I put, I guess I put 5 here. So I made, so I don't know what it means, but actually, but anyway, it didn't work exactly like we expected. And then it says here, x. This x argument is an R object. Now that's not clear, right? I said this help is confusing. You need to know a lot about R to understand the documentation. Currently, there are methods for numeric logical vectors. Okay, that's definitely not clear, right? And date, and time date, and time, and so it's very confusing, right? Right. And so on. So it's not that easy to use the help. Okay, they do give you some examples here. So you can try this. But anyway, even this is still too advanced for us right now. By the end of it, in a few minutes, this will be okay, but not yet. Okay, is everyone following me so far? Okay. Now let's go to the tutorial, because I'm going to give you a homework assignment in this tutorial, as well as homework assignment in here, as well as homework assignment in Wiley Plus, your text. Okay? So what I want you to look up is, on the web, look up Code School. Code School, 2 words. Okay, codeschool.com. Okay, and go to there. And this, they have a bunch of free courses, and then they also have a subscription for the non-free courses. And I don't think you need right now to create an account to start with this free course, but it might be that if you don't create an account, you can't do. They might have exercises that you can practice with, and if you don't create your account, you can't do those. But even if, it might be a free account, but you still need to do the free account in order to get access to the exercises, but I'm not sure of that. Anyway, click on courses. And this is, I guess, the list of all the courses. So if you want to learn how to make an iPhone application, you might look at this. And you want to learn about JavaScript and other things, you might look at some of these. But we're going to do one called Try R, which is a free course. Try R. Okay, so click on that. Try R. And you can start the course for free. Okay? So click on that. Oh. So you do have to create an account. Is that true? Does everyone get that? Okay, so click on create a free account and do that. And then do it. right back.
Name has also been taken. Tare.
Okay, so, I guess I already did this, so I have to, maybe I need to create a new account. I'll create a new account because it's not giving me the beginning. What does that mean, by the way? Does anybody have any idea of that? I don't think so. I don't think you know what that means in the population. But to give you a brief prelude to what we will study, these statistics, does it say how many people were interviewed?
8,000.
Where does it say that? Where? Ah, right. 8,860 adults, right? So that's the number of people that they actually interviewed, right? Okay, so like APU has 6,000 students, so it was like 1.5 times the population of APU, right? And hopefully they kind of randomly selected those students, those people, right? They didn't all come from like one city or something like that, or one neighborhood or one whatever, right? They were randomly selected. Okay, so anyway, how many were selected? About 8,800, right? Okay, now, but that's not everybody for example, in the USA, obviously. So this is only an estimation of what's really happening in the US, right? So 18% was in this survey, right? That doesn't mean that 18% of Americans are the same, right? Have the same opinion, right? Because it only tested 8,800 people, right, or so. So, so therefore what they're saying is, we recognize that this is only an estimate, right? And then because of basically the size of our population, we can say that the plus or minus error is 1%. So if you only interviewed 100 people instead of 8,800 people, you still might get the same statistic. You might get the same number, 18%. Right? Possible, right? But then your margin of error would turn out to be bigger because it's a smaller sample. Okay? So we need to study exactly how to get the margin of error. Right? They're just telling us it's 1%, but we didn't know how they got that. Right? So we need to study exactly how to get that. Okay? Okay, anyway, so that's what they mean. All right, let's go back to here. So this is the stuff that we're going to study in chapter 1. What is statistics, the types of statistics, then this concept of population versus sample. So how big was the sample in that last diagram? How big was the sample? Or let me ask you, did we ask everybody in the world, or did we take a sample of people? We took a sample, right? So how big was the sample? About 8,800, right? Okay, so the sample is 8,800. Now, as opposed to the population. The population means the whole, from the whole group from which you sampled just a few. You just sampled a few from the whole group. So what does the population refer to probably? It doesn't probably refer to everybody in the world. It probably refers to the US population. Okay, now maybe it could be everybody in the world if you kind of took your sample in a random way from the whole world, but then that would probably not be the same people that you got if you took a random sample from just the US, right? So it probably is just the US. Okay? So do you understand basically the idea of population versus sample? Okay? Okay, that's very good if you understand that. That's a big concept in our class. Basic terms, types of variables, and then some other stuff. So types of variables is important also. So suppose I want to know what your favorite beer is. Let's say favorite Japanese beer. Okay, so can anybody give me the name of some Japanese beer? Which one? Asahi. And how about another one? Kirin. And how about another one? Ebisu, and another one? Sapporo, and what was that? What did you say? Sapporo is another one. What else? Kirin, Asahi, Sapporo. What did we say? Ebisu. What else?
Orion.
Which one?
Orion.
What's it called?
Orion.
Orion, right. Orion. Anything else? Okay. So anyway, there's a bunch of them, right? Okay. So I could have a survey, and I could say, what's your favorite beer? And I could also say, how old are you? And I could also say, how tall are you? And I could also say, how much do you weigh? Okay, so what are those that I just mentioned? Favorite beer. And age. And tall, or height, I mean. And weight. Anything else I might want to ask? Country, or country. What? Gender. Okay, good. All right, let's start. Let's just stop with those. Okay, So since these can, depending on who I ask, these can all be different, right? And if I ask this person, it's one thing. If I ask somebody else, something else, right? It could be a different set of answers, right? Each one of these can be different depending on who I ask, right? So they're called variables because they can change. Just like x is called a variable, right? Because it can be 1, it can be 2, it can be 5, it can be 20. Right? So it's called a variable. So these are also variables. In fact, I could call this one x and call this one y and call this one z if I wanted to, no problem. Or I could call this one x1 and I could call this one x2 and I could call it whatever I want, right? Okay, so they're all variables. But it's useful to distinguish between some different types of variables. Now, these are all different variables, so you could just say they're just different, period. But you can also group them into kind of similar types of variables. So what I mean by that is that I'm going to say that this one, and this one are similar. I'm going to say that this one and this one are similar, and maybe this one, but actually I'm going to distinguish between this and the other two blue ones. So I'll put another thing there, because I actually want to call this a different type, actually. Okay, so how did I do that? Why are the three green ones, in what way are the three green ones similar and different from the others? Where you can't guess what I'm talking about. What's different about age, tall, and weight as compared to favorite beer and country? Nothing different? I mean, yeah, you could say they're just different, but they're not, there's no similar. They're not similar in any way. Then you don't know what I'm talking about. But can you guess what I'm talking about? No idea? Huh? Are what? Measurements. Yeah, that's right. Or what I want to say is they're numbers. Right? Age is a number. Height is a number. And weight is a number, right? But is beer preference a number? No, it's not, right? Right? If I ask this person, what's your age? They say I'm 18. What's your height? They say I'm 175. What's your weight? They say I'm 60. What's your favorite beer? It's not a number, right? It's something else. But it's still interesting to collect that data. In fact, it's probably more interesting than to collect the numeric data, right? Like, it's kind of more interesting to know people's beer preference than it is to know their weight, right? Or it's more interesting to know their store preference, which store they prefer to shop at, right? Than to know their age, maybe, right? Or something. Anyway, I think that actually the non-numeric variables are kind of more interesting, but that's just what I think. Okay? But anyway, they're all important, depending on what you're trying to understand. But anyway, it's useful to distinguish between different types of variables. So we have numeric variables, and we have non-numeric variables. So which are the non-numeric variables here? Favorite beer, country, and gender, right? Okay? So we sometimes we write them, we describe them as quantitative, is it quantitative? Maybe, I hope I spelled that right. Quantitative versus qualitative. So quantitative are the numeric ones, and qualitative are the non-numeric ones. Okay? So we use we have lots of different words that they use, but this is some of the words that we would use. Okay? Or just numeric and non-numeric is also. Okay, and that's an important thing. So they call them here types of variables, so we'll look at that in a second. And also, sometimes, like in programming, we might need to use these in programs. We might need to, in R, we might want to write a program that's trying to deal with this data. We collect these variables for everybody at APU, right? So we have 6,000 people, and we have all these, how many variables? 1, 2, 3, 4, 5, 6, these 6 variables about everybody at APU. Then we might want to use R to do something with that, like find the mean age, or find the mean weight, or find the favorite, the beer that is most people's favorite. No, not most people. The beer that's most popular. The beer that is most popular, right? That kind of stuff. Okay? Now, one thing is that I can find the mean age, right? That makes sense, right? That phrase makes sense, the mean age, right? Right? That just means you take everybody's age and then divide by the number of people, right? So that's easy, and that makes sense. But does this phrase make sense? Mean beer preference, does that phrase make sense? No, right? It doesn't make sense, right? You can't say the mean beer preference doesn't mean anything, right? Okay? You can't add up the beer preferences and divide by the number of people and get something that means anything. Right? So what does that means? That there's a good reason to distinguish between numeric variables and non-numeric variables, because there are certain things you can do with numeric variables you can't do with non-numeric variables, right? It's not to say that I can't use non-numeric variables, because instead of finding the mean beer preference, which doesn't make any sense, I could say what I already said, which is the beer which is most popular. Okay, but that's a different calculation, right? You don't add up the names of the beer and divide by the total number of people. That doesn't even mean anything, right? So it's a different calculation. So there are certain calculations that you can do with numbers, and certain that you can't do with and some calculations you can do with numbers you can't do with non-numeric data, and that's why we make the distinctions. Okay, so anyway, we can have different types. Now, in programming, sometimes this type of variable has a special name. It's called it has different names. The simplest name is it's like a 0, 1 variable, because it can be just one of 2 possible values, usually, right? Gender. I don't know, maybe there's more things, but generally not, right? 0, 1. Or it's also called a binary variable, again, because there's only 2 possible values. It's also called sometimes in programming they call it a logical variable. Basically that's the same thing, though. It just means there are 2, it means there are 2 possible values. And when you talk about logical, then you're usually meaning the 2 variables are either true or false. But the point is that they're just 2 values. Okay? So, gender, but of course it's definitely not numeric, even though I call it 0, 1. But basically it's not numeric. Okay, male, female is not numeric, right? So we could lump it together with this one and this one as just call it non-numeric, okay, or call it qualitative. Okay? So now in this chart, in this section there, they have types of variables here, quantitative, and then within quantitative they break quantitative down into different types of quantitative. So they have what's called discrete and continuous. So discrete versus continuous, all of our quantitative variables are called continuous. But if I asked you, I could talk about the number of cars in a family that a family owns. Number of cars owned. So is that numeric or non-numeric? It's numeric, right? What are the possible values? Maybe a family doesn't own any cars. That would be what? Could be 0. Could be 1. Could be 2. Could be 5. Right? So it's numeric. Okay? But could it be 1.5? No. Not, generally we wouldn't say 1.5 is okay to use. That's an example of a discrete variable as opposed to a continuous variable. So discrete means it can be this value, or this value, or this value, or this value, but not things in between. Okay? So it's not continuously filled up, right? They're not all these possibilities, one or another or another. There's still numbers. Discrete are part of numbers, but they're like that. Okay? Is that clear? So those are called discrete. But these are not discrete, right? You could be, 18.6 years old, or you could be 18.6666667888891 years old, right? If you measured up to the very fraction of a second, right? So that's called continuous. And the same thing with height and weight, right? If you really could measure really carefully, you'd say you could take on any value, right? Whereas the number of cars that you own is not like that. Okay? So we have two types of variables, discrete and continuous, within the category of quantitative variables, right? Within that category. And then another word for qualitative is categorical. In other words, they're category, right? It's a category of variables, right? So like we said, favorite beer. So we can have this one or that one or that one. Those are categories. Or that's a category. Those are categories. Okay? And then, right. Okay? And so here we have this chart. We have variables. We have two types, quantitative and qualitative. Okay, and then within quantitative, we said we have discrete and continuous. Okay? And then they ask you to identify different variables. Are they quantitative or qualitative? For example, number of people in a family. Is that quantitative or qualitative? Quantitative. And then, since it's quantitative, you could ask a second question, which is what? Is it what or what? Is it discrete or continuous? So what about this one? It's discrete, right? Because you can't have 3.8 people in a family, right? And so on. Okay? So it's like that. Okay, so I'm going to give you some assignment to do in this course, and you have to register for the course to see the assignment. Okay, so when you do that, you should see here, when you register under assignments, you should see some assignments. Right now they're right. Okay, but I'll put some in there, and you're going to have to read the text and do the assignment. And then, also, you have to register for that other thing, which we weren't able to do. And I'm going to, and I want you to go through sections 1 through 3 in there and be prepared for a quiz. So sections 1 through 3, or I'll just say it for next time, sections 1 and 2. Okay, so that's section 1 is using R, and section 2 is vectors. Okay, so you'll find it very easy to navigate, to use this course. It's really easy and pretty fun to do. It's very simple. they feed you all the information. So you just say, what is this? And you just give the answer, and then they tell you if it's right or not. So there'll be a quiz, though, on R, on sections 1 and 2. Okay? And basically, I'll give you probably handwritten questions, not literally to fill in R, because I don't have any way of checking that really. So maybe it'll be through Blackboard. That means I can set up a course in Blackboard. And then I'll just have a few questions that you'll answer next time. And it'll just be on these two, which we did most of everything in using R already, and then just vectors. And vectors are very simple. Vectors just means, remember that list we typed here, like these here? This is called I call it a list, right? But in R it's called a vector. It just means a list. Okay, so this is a list, this is a list, this is, I'm sorry. Even though there's only one element here, like, it's still actually called a vector with just length 1. And this is called a vector of length 8. And this is called a vector of length 1, 2, 3, 4, 5, 6, 7, 8. Okay? So it's just a list. Okay, but they use the word vector. But don't worry about that. Okay? So that's kind of a lot to do. And this course is demanding. It is demanding. But it's one of my favorite courses to teach. I like it. And you can learn a lot, but it is demanding. Okay? But I hope that when you come out, you don't feel completely confused by statistics. Now, one thing and last thing I want to say is, what I recommend for those of you who don't feel really qualified or really good at this subject is that you do one thing, and that is you take 10 minutes one day or 2 hours before the class to go through what you think we're going to be covering in the next class, and just try and read it quickly and understand what it's about. Now, obviously you're not going to understand, but just try and get a feeling, a framework for what we're going to do. That will up your understanding a lot. So I request that you, if you don't feel that you're really good at this subject, that you do that. Just 10 minutes. Just go through what you think we're going to cover. Okay? It's kind of like what they call active learning, in a way. Right? Makes you a part of the game. And that's a big difference between that and just sitting and listening. Right? It really makes a big difference in the way you can learn and where it goes in your brain, actually. It makes a big difference in where the information goes into your brain. So that's why I think it's good. Okay? Okay, that's all. Sorry to keep you late. Try not to do that ever again.